Good morning, and welcome to the session on metadata. My name is Gunninger, and I will be chairing this session. I have one announcement before we embark on the program. I'm taking over as the national coordinator for the Norwegian contribution to CLARIN, CLARINO, and the national coordinator for Norway until now has been Professor Konrad de Smet, who many of you know, of course. He will be retiring by the end of this year, and his wife and our colleague Victoria Rosén has also retired recently. So tomorrow in Norway we are arranging a surprise seminar for them with invited speakers presenting new work based on language resources, tools, and infrastructures related to the two of them. That means CLARIN and ERIC, the tree bank infrastructure. So many of you have asked me during these days to give my regards to them, and it was Francesca's suggestion that we could actually just supply a card. Now we'll start over there, and we pass it on, and anyone who would like to writes a short greeting for Konrad and or Victoria. And if there is not enough room here, I also added some extra notes, so I can fix it afterwards and create some kind of cascading thing if necessary. So much about that. I'm happy to introduce the first speaker. So I'm introducing Martin van Gompel, who is going to talk on an automated software metadata harvesting pipeline. Please.
Hey, hello everybody. I will be presenting an automated software metadata harvesting pipeline, which we have developed in the Dutch CLARIAH project. And we call this track the FAIR tool discovery track. And FAIR is, of course, the well-known acronym we all know for findable, accessible, interoperable, and reproducible. And our focus is on the F of findable, because our objective is to help researchers to find and to identify tools that are suitable for their research. And tools here is a very broad concept. It means any kind of software, regardless of the audience it's intended for or what it's written in. Is it a web-based software or a local software? All software is something that we want researchers to be able to identify and find. For this to work, users must be able to make an informed enough judgment whether software is suitable for their needs. And how can they do so? They do so on the basis of the metadata of the software that is available. And for that, the metadata has to be complete and has to be accurate. Of course, there are many existing software catalogs in the world already. And also this I count as a very broad concept. So even like an institutional webpage with tools could count as a software catalog. And there are, of course, many more specialized systems. But what we see in these systems is that information is often and quickly outdated, because many of these systems are manually curated once. There's usually one person maintaining them, and then, well, they lose the track of the actual software, because software is not a static thing, but software moves in a moving ecosystem, and version information is very important in that moving ecosystem of software. You want to exactly know what version of the software is described, because there may be big differences between versions. This version keeping is, of course, also very important for provenance reasons and for scientific reproducibility. But other examples of outdated systems are simply broken links, these simple things that do unfortunately occur in practice. Okay, the next point is that information that is in software catalogs may often be incomplete. So some details that are very important to researchers to make a decision on whether the software is suitable may be missing from the metadata. For example, things like maintenance status. The researchers wants to know, is the software ready to use, or is it still in development? And is there somebody I can go to if I have questions about the software? Many of these things boil down to the disalignment between the software in the system and the actual software itself, where information is often duplicated and not properly aligned because the system is separate from the software. And there are, of course, multiple existing metadata schemes in existence. Well, what do we propose for this? We have developed a pipeline for automatic software metadata harvesting. And the idea is that we have an automatic harvester that periodically runs and harvests software metadata from the source. So this is not really just another software catalog system, but we are an ingestion system, a harvesting and conversion system. And our aim is to feed existing catalogs that are already out there and that are user-facing with our data. So let's take a look at what we mean by bottom-up harvesting from the source, because that's the most important thing. The source means that we have the tool developer on the left-hand side in the graphic here, and he or she maintains the source code of the software and also maintains software metadata that lives right alongside the source code. So it lives in a version-controlled repository like Git, and it is published somewhere publicly in a software forge like GitHub, for example. It doesn't have to be GitHub, but that's one of the common examples. This is the main source. And when we do it this way, we keep the metadata with the source, so it is properly versioned. The version control system takes care of that. And the full authorship lies with the developers. The version is exactly described that the metadata is a part of. The idea is also to have no duplication and no intermediaries in this way by going straight to the source. I should also mention the second source you see here, which is web endpoints. And that is when we talk about software as a service, which is of course very common nowadays. Lots of things are offered over the web as a service. And then we also have an additional source of metadata, which is the web endpoint or the website or whatever kind of endpoint it is, which itself can already incorporate a lot of metadata. But this is a secondary source. The source code is the primary source, and there's always a relation between these two, because when you have a source code product, the source code doesn't know when and where it gets deployed and by whom. So that's why you have this distinction. So the next part in our schema is that we have the harvester. This harvester is a tool that automatically checks all these repositories. And with all these repositories, I mean we maintain a list, and that is one of the only manually curated steps in our pipeline. And that list contains all the repositories where the harvester should look. So in our case, for the CLARIAH project, it contains all the CLARIAH software. And it contains both the source code URLs and any endpoints that may be related to it. And the harvester then periodically checks all of these, and it does so every night. And for each repository, it finds and it collects the various existing software metadata schemes that may or may not exist in that repository. So these can be very heterogeneous because there are many existing metadata schemes in existence, and our idea is not to invent another one, but to reuse what developers already use. Because many software ecosystems, for example, the Python ecosystem, already have a kind of way to describe metadata because they require that for their packaging and things like that. And we should reuse that information and not duplicate the information. So for Python, you have things like the pyproject.toml or the setup.py files. For something like JavaScript and NPM, Node.js, you have the project.json file. For Java and Maven projects, you have the pom.xml. So you have all kinds of existing software ecosystem metadata sources which we can use. Let's take a look at this example of one of my projects on GitHub. And here in red triangles, I highlighted everything that is metadata that we can actually extract. So you see in the file list, you see a number of files that our harvester can read. For example, the license file, which contains the full open source license of the software. And that's the GPL license in this case. And you see that GitHub itself also already detects that this is the GPL license because in the right column, you see GPL indicated. Then you see at the bottom, you see in the README these kinds of badges, which are nowadays very common. And they are also a form of metadata. These badges express some kind of metadata about some aspect of the software. For example, one of these badges is the repo status badge, which indicates the maintenance status. And one of them links to a continuous integration service to see if the tests of the software work. One links to the documentation. well, there are all kinds of badges in existence, and a number of them we can interpret with our harvester and convert to proper metadata. Then there is, of course, the information from the Git repository itself. Because we have Git, we know exactly who the contributors to software are. We can also identify what programming languages were used in the project. And last but not least, we can, because this is GitHub, there's some extra metadata associated with GitHub repositories, like a description, which you see in the top right corner here, and a URL and some tags. So all kinds of metadata that can be extracted from a random project. So what do we do with this metadata? We harvest all this, and then it goes into what we call the converter. And this converter takes all these heterogeneous metadata sources and converts them into one single and uniform linked open data representation. And for that, we use the CodeMeta and schema.org vocabularies. CodeMeta is an existing project which does exactly what we need. It defines mappings between existing metadata schemes to one single vocabulary. And they built on top of schema.org, and they contribute back to schema.org. So that's a good existing initiative which we can build upon, so we don't have to reinvent a new vocabulary. Of course, this also uses additional vocabularies on top for specific fields, such as the SPDX vocabulary, which is a well-established vocabulary for licensing, the repo status vocabulary, which I already briefly mentioned, as it was one of these badges that describes maintenance status, and of course, all kinds of additional vocabularies can be thought of. So the result of this conversion process, which is done for every repository that is harvested, is a single codemeta.json file which represents the unified metadata. This codemeta.json file can be committed back into the source repository. So then the authors retain the full control, and they can edit it themselves if they want. They don't have to, because if you don't provide such a metadata file, then the harvester just runs every night again and extracts it from scratch. So here too, the authorship lies with the developers, and they have the final say in how it goes. So now we look at the entire architecture scheme. The top end I have just discussed entirely, but what happens with this metadata once we have it? Well, it goes into what we call a tool store. We built our own simple front end on top of our system to display all the data that's in it. And you can see that on tools.claria.nl. But this is not the actual endpoint yet, because our idea is to propagate the metadata of software to existing software catalog systems. In the CLARIAH project, we have developed a system called INEO, which is in use, well, specifically for CLARIAH. But in the CLARIN context, of course, there's already the Virtual Language Observatory. And we are also working on getting a pipeline to that, which proceeds via CMDI. It does a conversion of the JSON LD to CMDI, and then the idea is that it goes into the Virtual Language Observatory. And this is done by Menzo Windhauer, who is probably in the audience right now. The next thing we can do, we haven't started that actually yet, but the CLARIN switchboard is of course a good candidate for being a metadata target. They right now have their own metadata scheme and their own Git repository where they keep it and where you manually add metadata, but it might be envisionable to do that automatically in this way. Last but not least, there is of course the SSH open marketplace, and in collaboration with people from Daria, we are working on a conversion to get our metadata ingested into their pipeline, into their software catalog. So, and then at the end of the whole thing, the scholarly user accesses either one of these four software catalogs or our own simple software catalog. Okay, this is a small screenshot of the index of our own software catalog system, which shows all the data. It's not the prettiest, but it's the most verbose, and it shows everything that's there. Here you see one of the pages of one of the software tools that has been harvested. On the right-hand side, you see all kinds of metadata. Everything is made linkable whenever it is linkable, of course. And everything, of course, is linked open data. And this front end is not just a front end for end users, but it is also a Sparkle endpoint, and it can be queried over Sparkle. Here you see an example of the same tool, but in the INEO system, which is used in CLARIAH, and you see that it is a much sparser representation of the data. But it is the same data that comes from our pipeline. Okay, next I want to discuss some of the challenges we have in this approach. Of course, one of the main things is the challenge of consolidating all these distinct vocabularies. But that is partially solved because the CodeMeta project does a lot of that. And they define all these crosswalks, they call it, between different metadata formats, or between all these metadata formats and their own standardized representation. And we just adopt that. Then the challenge is dealing with extra domain-specific vocabulary. For example, we want to ask tool developers to provide some extra metadata that cannot really be automatically extracted from the information that is already present in metadata schemes. For example, we want them to describe a research activity using the Tadira vocabulary, or we want to want them to describe a research domain using the NWO categories, which is the Dutch funding organization. Now, these kinds of things are trickier because they require some effort on part of the developer to actually provide extra metadata. They can easily do so with a small CodeMeta harvest file in their repository, which only adds the extra vocabulary. So the harvester knows, okay, we can do our harvesting and we can take these extra things and add them to the result. So last but not least, I want to talk about validation and curation a bit before I run out of time. And that is, of course, everything is automated. The only manual point is the decision, is the tool going to be included in the repository or not? And then the question is, how do you allow curation and collaboration? Also, when everything is stored at the source, doesn't that make it difficult? I don't think it makes it difficult, because forges like GitHub have very solid contributor mechanisms in place. So even though the authorship lies with the authors, with the developers, everybody can just send pull requests to these authors with metadata suggestions or make comments on the metadata. Of course, the authors do retain the final say, but these mechanisms are in place. How do we assure metadata quality? Because that's important. We want the metadata to be good. We harvest the harvested metadata is evaluated against a schema, and the schema tests all the metadata that is harvested against for completeness and for accuracy. And we have made this schema on the basis of a formulated formal document, which we call the CLARIAH software requirements. That looks like this. It says with terms like must, should not, recommended, optional, what kinds of metadata we expect and what we expect people to provide. So the formal schema that has been made on the basis of that provides an automatic report to the tool developers. And that report looks something like this. And that mentions all these points from the software metadata requirements which are not met. And there are various degrees of severity for violations and warnings and information. And then on the basis of that, you get a ranking expressed on a level of 0 to 5 stars. In this example, you see that this project got a 3-star rating, and that indicates the software metadata quality. And in my last slide, for propagation to the actual software catalog systems, we of course set some kind of threshold. So you need a certain level of metadata quality to get your tools in the catalogs, and we use 3 stars for that. And you see in this small graph here that we have 114 tools, and this is how they score on the star level. And you see that the majority is on the good side, but of course there are some tools that score worse and that require some work, because one of the main challenges to end this with is actually the human compliance. That's why we do as much as we can automatically, but when you ask a little bit extra of humans to provide extra metadata, that's the hardest trick. So the more you can do automatically, the better. Okay, this concludes my presentation, and thank you all for your attention. If there are any questions?
Thank you. We have time for 2 questions.
Thank you very much, Martin. Impressive work, I would say. it's really a need that that your solution covers. But this remembers me the times where the web was growing and growing and growing, as we are now getting more and more resources published, and then even the search engines in those days were unable to really provide solutions to help people to find the page containing the information that they wanted to get. So don't you think that we are reaching this same situation? We have a lot of resources, but now when it's time to look for a resource, you have so many tools that you don't know how to rank them. Maybe this quality is a valid score. I wouldn't say that, because it's more related to the number of metadata and correctness of the information collected and arranged, not really on the usefulness of the tool to your needs.
Yeah.
Do you think that a very interesting starting point for your system wouldn't be to harvest all the research papers, as Google does with the pages? So you extract the URLs of the tools being mentioned and being used by the research community. So you can get first a starting point to know which tools are being used, okay, even those that are not in the official catalogs, and also a kind of rank to know who is using what, how often, if they are more popular or not. What do you think about that possibility?
Yeah, it sounds interesting, but I do have to remark that this system is specifically designed now to work on a manually given list of projects. For example, in the CLARIAH project, our idea was just, we want to have a good image of all the tools that are available in CLARIAH. So all the tool providers from CLARIAH have to register their URL with us. Our system is not intended to really go out in the world and look for software. So
I'm saying another system that is able to harvest all that information from papers. So you get that list from there, but also with very interesting information. So who is using that, in which research?
Yeah.
So you can add all that and even score.
Yeah. No, I do think there are interesting possibilities in harvesting more and looking at papers. Or there is an existing project which is called the SUMF project, which also uses CodeMeta and which more deeply analyzes these README files in repositories with NLP techniques, also for metadata to extract. But that's one step we did not take in this project. We wanted to extract the easily extractable information and not really the things you have to dig for much deeper. But there is, of course, a wealth of information out there.
I need to stop you there. We need to actually move on to the next speaker. So I say thank you to Martin.
Yep. Thank you.
So the next speaker is Nanan Liu. Please.
Good morning. We are very happy to present a core metadata schema for interpreting corpora and its implementation on the Unified Interpreting Corpus platform, UNIC. Let us start by answering Reviewer 2's question. Reviewer 2 asks us, is the use of interpreting corpus to mean a corpus of the products of interpreting, in the sense of the products of translation of spoken language well established? Basically, was before in the sense of is correct and was after in the sense of is inaccurate. Outside interpreting studies, the term interpreting corpus is interchangeable with interpretation corpus, sign language translation corpus, not just spoken languages. Speech translation, spoken language translation, or speech to speech, speech to sign, sign to speech translation corpus. We define an interpreting corpus as a sample of transcripts, sign annotations, glosses, or recordings selected to represent immediate, which is the biggest difference between interpreting and translation, in the target language based on a presentation in the source language. We addressed 3 research questions. Empirically, how are interpreting corpora described with metadata, namely structured information about the corpus? Conceptually, what should be a metadata schema for interpreting that adheres to principles of scientific data management? Technically, how do we implement the schema on an open source platform? I don't need to repeat the FAIR principles here, you are all converts, but I do want to highlight the relevance of the CARE principles: collective benefit, authority to control, responsibility, and ethics. It's relevant to interpreting because many interpreters work with indigenous languages and in privacy-sensitive settings, such as child language brokering, multilingual children interpreting for their monolingual parents, asylum seeking, and mental health settings. There's no dedicated open access infrastructure for interpreting and translation corpora. In CLARIN, the metadata for parallel corpora are much poorer. There's no page for us in the resource families. And a previous survey with translation students testing the VLO shows that they regard the metadata quality as neutral and they were unsatisfied with the search results. We designed our schema and unique based on the value-sensitive design approach, a tripartite approach to conceptual, technical, and empirical investigations to account for values when designing technology. First, we identified FAIR and CARE principles as our conceptual guidelines. Technically, we followed some CLARIN national centers to use open source backend databases and front-end interfaces. Empirically, we collected corpora in 4 languages from 10 repositories. We read about 1,900 publications to see if an interpreting corpus was analyzed or presented. To understand their degree of fairness, thank you. We conducted an automatic fairness evaluation using the FAIR evaluator. Our evaluation focused on 6 metadata records. As you can see, the bottom 4 are associated with CLARIN. We then conducted a manual overlap and gap analysis. Overlaps are exact and partially matched, synonymous, and related terms such as mother tongue, native language, and first language used in more than 50% of the metadata. And the gaps are what's in most of the data, but not found in the metadata. Because of their relevance to most of the interpreting corpora, we made the overlaps and gaps compulsory in our schema. We then designed our schema following the tripartite analysis. Conceptually, we followed the principles, especially collective benefits between spoken and sign language interpreting. We followed the ISO standards on SIMD format and the rules of relational database design. We based the specification of our schema on the interpreting corpora we collected and our community knowledge. Specifically, we examined the metadata of 4 corpora in different settings and made those metadata terms optional. We collected the stakeholder feedback to our schema and unique to improve on the technologies. We distributed the schema at 2 translation and interpreting conferences and to a corpus linguistic mailing list. We also followed the previous study to administer a survey on the implementation of the schema on unique, involving our students and colleagues. Most of the colleagues surveyed have created their own interpreting corpora. Moving on to the findings, we collected 124 interpreting corpora in 38 spoken and 8 sign languages from almost 390 publications. The data were collected from 26 countries and regions across the world. However, only 5 of them have their data openly available. Despite being data silos, the interpreting corpora do have some commonalities that can be coalesced into a core metadata set. They describe 8 types of settings. Their size, which amounts to 39 million tokens and glosses for sign languages, and almost 6,000 hours of recordings. They describe the corpus processing such as anonymization, transcription, annotation, and alignment. The uniqueness of interpreting corpora vis-a-vis translation necessitates a domain-specific interpreting metadata schema, because many of the annotations were done manually, and the alignment can be at textual and temporal levels. In translation corpora, we usually see the source and target side by side. But in interpreting, the temporal alignments between the video, audio recordings, between the recordings and the transcripts are relevant to a lot of our research questions, such as the latency in simultaneous interpreting. The automatic analysis, we analyze the results by assigning a score of 1 to a metadata record that passes a test, a full circle, a half circle to a partial pass, and 0.5, and a empty circle or 0 to a failure to pass a test. As you may remember, the 4 on your right are associated with CLARIN. The 6 metadata records are relatively findable, accessible, interoperable, but they are hardly reusable. Those associated with CLARIN are fairer, that's why we are here. Our schema consists of 95 elements in 10 components. 4 of them are compulsory, highlighted in red here. We reused 92 CLARIN-defined concepts, and we also introduced translation and interpreting specific ones, such as source text, interpreter, and alignment. The mandatory elements are gathered from the overlaps and gaps, as you can see some examples here. We implemented the schema on the first open access and open source data infrastructure in translation and interpreting studies. If you missed our demo yesterday, we also have an intro video on YouTube. UNIC currently hosts the metadata of 125 interpreting corpora and the data of 2 corpora. On the Explore UNIC page, the filters correspond to our compulsory elements. The Register Your Corpus metadata page corresponds to the corpus component. And UNIC automatically converts this information into a landing page of the corpus. Users can also upload the specific metadata files according to our template based on the schema. UNIC enables cross-corpus search and download. We also designed an opt-out mechanism. For instance, the data subjects, the speakers, signers, can contact us and have their data removed in our database. Our students perceived the UNIC filters as useful. In comparison, the score assigned to Velo in the previous study was higher, less useful. And they also pointed out that they want to see the source actor, actor being an umbrella term for speakers and signers. They want to see the speakers' accents represented, and also the mode of the corpus data with audio multimedia materials being more useful for their interpreting practice. We've just heard from 4 colleagues who also rated UNIC as more useful than Velo, and they also want to see multimodal corpus being singled out, but the sample is quite small right now. In conclusion, we illustrate a value and consensus-driven approach to open and sustainable metadata based on conceptual, technical, and empirical investigations. Thank you.
Thank you very much. We have time for a few questions. Short questions, please.
Yes, thank you. Very interesting presentation. I think it's a rather unique thing that you produced there, and very valuable. Now, you mentioned at the start the resource families, where you do not have a specific resource for interpretation corpora. I think you're right. So there's one way perhaps to introduce one, but the other is to look at the parallel corpora which are there. Maybe you already did some. Okay, thank you. I would like to have your comment on that.
Yeah, I did check the parallel corpora page. The problem for us is that you represented the languages as like language A and dash language B. We don't know, like, is the translation or interpreting direction from A or B or A or bidirectional? That's really relevant to a lot of our research questions. So that kind of representation isn't that useful for us.
That looks like a good way of collaboration there.
Yeah.
Thank you.
That's why we're here.
Exactly.
This sounds like a very, very good way of showing how to create a new SIMD profile by using the investigation and what kind of metadata do we have. So how long did it take for you to create this SIMD profile for interpretation corpora?
That's a great question, but the thing with the creating a schema, the good thing is CLARIN already have so many good examples. We followed primarily the metadata schema for learner corpora. So most of the time we spent is on reading the publications, which took about 2 months, and then the generation of the schema itself is relatively easy because we have so many good examples to follow.
Thanks also on my part for this very interesting work. And of course, I think that the next step would be to make this metadata visible via the VLO. And I mean, I can only say that we are looking forward to collaborate with you on this topic. Another aspect is, of course, that there is a lot of domain-specific knowledge or expertise that you have gathered. So I just wanted to ask you if you are aware of the fact that CLARIN has also a network of knowledge centers, and that you could, of course, also become a hub of knowledge for this type of resources.
Thank you so much for the suggestion. Yeah, right now there's only one knowledge center on translation, corpora, and terminology at the University of Vienna. There's no knowledge center on interpreting yet.
That's why I asked.
Yeah, but we do want to make things happen. Yeah.
So I say thank you to Nanan. The next speaker is Dan Bruder on vocabularies in CLARIN, problems and solutions.
Thank you. Almost didn't make it. Okay, so my name is Dan Bruder, currently working for CLARIN ERIC, and in the past, together with co-author Jan Odijk, for the Dutch CLARIAH project. So this presentation is about our experiences with the CLARIN metadata infrastructure, specifically or especially about the role of vocabularies there. Yeah, this work with the CLARIN metadata infrastructure was stretched out over many years, I should say. So I want also to make the disclaimer that some of the problems, the problems could have been resolved or alleviated over the years. So if so, we're quite happy, and we hope that our nagging to the developers has contributed to this. So yeah, the challenge for us was how to improve discovery of tools and services And for that, we developed a new CMDI profile. I would like to call it CLARIN Service Descriptions, but I understand that originally the real name is CLARIN Software Description. There's a little difference there, but we can discuss that later. And this profile was created to describe the output of mainly Dutch CLARIN-related projects, but also we applied it to Weblicht. In total, I think there are more than 300 records created. Part of this profile are two important vocabularies, tool task and linguistic subject, and especially tool task is interesting, and it should also be useful in other profiles, any profile that does anything to describe services and tools. I mean, the name tells it all, right? Tool task. What's a tool supposed to do? So in 2017, these vocabularies were offered for uptake in the CLARIN concept registry using, as recommended, an Excel sheet. This went wrong. We will talk about that on another slide. So now we have put it into SCOS format, easy publication using SCOSMOS instant elsewhere. And also what we liked a lot was the ability to support multiple hierarchical relationships and now linking to other sources of wisdom, other vocabularies and semantic registries. Why did it went wrong with the registration in the CCR? Well, we can imagine a few things. General lack of resources, lack of the appreciation of importance of these vocabularies, and probably the communication also was not optimal. I don't think there was a specific support line for researchers or projects offering a new set of concepts for registration. So the CCR coordination group managing and deciding on adoption of new concepts is not functioning well. I don't think we are the only one that had problems there. There were proposals over the years, I think, to improve the functioning of the CCR coordinator group. And I recently heard maybe a decision is taken to put it into the scope of another committee. I would say any change is welcome. And certainly pumping up the prestige that you get by working in the CCR group, this coordination group, would certainly help. Providing some extra resources there and having a clear assignment for that group will certainly help. But also we should not forget that I think working on semantic registries in our domain is kind of a hobby project for most. There are other disciplines where this work is taken much more seriously. Thinking about biomed, for instance, where it's part of the job. Then there is the matter of the vocabulary hosting. There is not so much choice there. Under SIMD 1.1 version, only embedding the vocabularies in the profiles, in the components was supported. 1.2 supports also remote vocabularies, but only if hosted by CLAFAS. And I don't know if that's such a good offer. If you look what's in CLAFAS, it's only an old version of the ISO 639 there. There are the same vocabulary is available from other registries. Thinking about the DARIAH vocabulary service, for instance. Yeah, so we decided to have our vocabularies hosted in another, well, not another project, but in a collaboration that's available from the Shock Network. They offer a Cosmos instance, and it's more easy to get your vocabularies hosted there, the SSH Vocabulary Commons. What we liked about it is that Cosmos supports hierarchies, and it's tended by a group of experienced and very responsive operators. We got more than our money worth, I think, there, in that they started also to make all kinds of remarks on how we used SCOS, etc. And we didn't count on having such a responsive group of people there. So hierarchies, we just mentioned it, in vocabularies are essential. Yeah, for human metadata creators, but also users, hierarchies facilitate easy search for items that you do not know yet. If you can support multiple hierarchies, multiple parallel hierarchies, that's even better, because you do not know every hierarchy there, but you might at least know one of them. But note here the difference between what I call selectionable broader concepts. If you have the taxonomy, the hierarchy, sometimes selecting a broader concept, the intention is indeed to select that value. But in other cases, you only want to offer that broader concept as a kind of grouping tool. So you should make a difference there. SCOS does not automatically support that. You have to make some kind of intrinsic agreement that you will use the broader concepts in that way. But of course, you can do what you want in SCOS. Your tools have to support it. And that's not always the case. So as an example, look at the two pictures. Easy selection of concepts using a hierarchy. And the other is, well, taken from the VLO, where if you have just a flat list, you can only have iteration through the pages, trying to find something that fits your need. Not ideal. Yeah, so CMDI imposes, or at least tries to push you into some direction with respect to vocabularies. And I would say, why isolate ourselves? Isolate yourself in having concept definitions, preferably from the CCR. That CCR is not efficient. I mean, do we have an efficient registration and evaluation procedure? Did we manage to use the CCR in limiting proliferation of concept? Does it contain a large number of high-quality concepts? These are rhetorical questions, of course. Our idea is no. And there are more sources of wisdom around here, Wikidata, schema.org, and you can already use them, but you are kindly pushed to still using the CCR. Our proposal would be to have also other recommendations there, but we get to that on the recommendations page. And the other thing is the vocabularies embedded in profiles or hosted in CLARIAH-ES. I think it's an understandable argument to say, yeah, but we control CLARIAH-ES and we can offer stability there. That's an understandable argument, but I think it should be a decision for the metadata modeler and metadata, the creator of the metadata. And you ask yourself, is CLAVAS now more reliable or useful than other such platforms that are out there? No, I would say. We have had we have seen the problems with CLAVAS too. So collaboration, use other people's, other disciplines, platforms there. So one example of an, let's say, collaboration with others on other disciplines would be about merging of vocabularies. It's not difficult to collaborate. For instance, in the case of shared and overlapping vocabularies. Maarten van Gompel in the first presentation mentioned already Tadira. Which is has good support in the sense there is a community behind it. And Tadira covers the broad digital humanities activity classifications, while our tool task vocabulary is specialized for CLARIN, doing NLP, for instance. You can describe that much more specific. And what you would like to do, because we do have common tools with the DARIA community, the SHOMP, the SSH Open Marketplace, and their INEO, which was already mentioned by Maarten also, they use Tadira. So, but you cannot get detailed enough classifications there. So our idea would be to try to merge those vocabularies. But if you merge vocabularies, you also get problems with what kind of editorial authority is then in charge of it. Huh? So our idea there is, and this is something that we investigate in the SSH Vocabulary Commons group, which is a network, but also offers this instance of the vocabulary platform is to try to go to a situation of merge on request. So you both have your own editorial domains, but if you need a new version of, let's say, the merged vocabulary, for instance, for INEO or the SHOMP, you can press a button. Now we are investigating this, and we hope that with knowledge languages like RDF and with OWL, we would be able to get this going in a nice way. But that did not work yet. But I think we could also devise something with templates and scripts just to do it by running a script. This would allow us to keep our separate editorial responsibilities. Yeah. Okay. Thanks. Yeah. And another, let's say, problem that we encountered, it's a side matter, but we still want to mention, is that because we worked over many years, we had quite a few, let's say, changes in staff, and there were problems related to our teams working with different persons, and they leave, and you have to transfer ownership of profiles and components, and that did not go that easy. I think we needed one of the developers to have a direct intervention into the database to make this work again. So you have to anticipate such situations where researchers work for several years with different teams on this. So flexible write, configuration and support options are required here. Okay, last slide, the recommendations. As you, I already mentioned flexible group management, etc. I think they can do that, that's not a problem. But important things are allow for concept definitions and vocabularies to be provided from outside the CCR and from outside CLAVAS. I think this is really important. Open the silo. I mean, silo is a heavy word, but still, open the silo. So CMDI should support external remote vocabularies that are hosted elsewhere. Make sure that CMDI tools, such as the metadata editors, and there was a poster on an editor, such as metadata editors, CCR, the component registry, and the VLO can use hierarchies to facilitate finding and selecting values, so that you promote reuse rather than thinking, oh, my concept isn't there, I have to add one. And have at least one CLARIN-supported CMDI editor that supports hierarchical selection of items. Revise the governance around the CCR. Already mentioned that. You can ask yourself, do we actually need complicated governance? Benevolent dictatorship is one of my favorite governments thing, but you have to shoot a dictator from time to time and install a new one, right? So it's dangerous also to do that. But most important, I think, is you have to put clear tasks to any governance there and provide adequate resources. So some extra money would be welcome. Okay, thank you. Questions?
Yeah, questions.
There's time for a few.
Yeah.
Thank you very much for the very nice and interesting presentation. You mentioned several times the SSH Open Marketplace and the notion of workflows, and I really liked your, towards the end, suggestion of creating a workflow or workflows for instance, creating a CMDI profile for a different type of data set or data type. And I was wondering if you would be willing, I think it's a great idea to prevent losing knowledge when people leave from teams by rendering this knowledge into workflows. Maybe they could be implemented in the marketplace to have open information, open knowledge. Would you be willing to consider this using the marketplace and the workflow item from the SSH Open Marketplace to put in there the knowledge that you have to create, for instance, CMDI profiles?
Well, I think it's the initiative should come from the marketplace. They want to be, how do you say?
There is a workshop tomorrow.
Huh?
This afternoon, there is a workshop this afternoon.
Yes, I won't join that, but you have my blessing, I would say. I would encourage the people behind the marketplace to try to really show the added value of the marketplace for all the infrastructures that support it. So that's not only DARIAH, but it's CLARIN, and it's also CESTA. And they should try to, with let's say, the vocabularies they are using in the marketplace to satisfy the need of the people from CESTA and CLARIN in classification of recommended tools or recommended workflows. The CLARIN people and the CESTA people should feel comfortable using the vocabularies that are in the marketplace. And I think with Tadira, it's a good step in the first step, but it is still too general. You need to be more specific. You need to be able to be more specific there. And adding the CSD tool tasks, and Jan and I have looked at it. There are a few overlaps there, but there are quite a few concepts from tool tasks that have to be added there. But the problem usually is not the tech, or in this case there was a technical problem, but it's usually not the technology, but how do you satisfy the editorial responsibilities that people have or are getting. And there I think the marketplace should know what is around there in CLARIN, but also in CESTA. and liaise with them. What do you need? What would you need to be able to add a recommendation for a certain solution in the marketplace? Does this answer your question? Okay. Martin also had a question.
Yeah, Dan, thanks very much for your presentation. And I don't have a question. I just wanted to say you have been heard. So
that's good. I like to be heard.
Just 2 days ago, the technical committee assumed overall responsibility for the CLARIAH system, and so assisted by the CMDI task force. And so this is on our radar. So you have a number to call to, currently mine. Of course, assuming responsibility is fairly easy, but turning it into practice is what we are working on in the future. So how do we get, when new suggestions come up, what's the review process exactly, basically what you said, and this will be a topic actually in our next meeting. So we will be working.
Okay, great. It's great. Like I said, we like to think our nagging has led to some success.
It did
over the years, and it's great to hear that we have now dictators or what.
I would like to keep this actually fairly democratic. So.
Well, you know that's all fine. But I think the most important is that we will be able to use external sources of wisdom. So external vocabularies, external concept registries. This is great. And I already talked with Menzo, and he wants to make his point, of course. Okay, sorry.
Sorry.
Yeah. Sorry, Menzo. You have been heard by me at least.
We need longer time slots. I'm introducing Torsten Trippel. Please.
Today I'm going to address a topic that all of us will face one time, some sooner, some later. So this our situation. We have a problem. So we've been running a repository system since 2010. So we were really early on in this whole CLARIN process, etc. So originally we ran a Fedora common system based on Fedora 3. We had we took it out of the box basically and added some extensions, having CMDI support. We had a data ingest procedure. We had a data maintenance procedure. We had to change our OAI PMH implementation because OAI PMH originally couldn't handle CMDI, stuff like that. 2010, okay, there were some CC BY licenses coming up, but it was not really something that we were so aware of in our community. We just started to discuss the licensing issues. Later we ported our system to a Fedora 4 system. That was about 2016. We disabled the original backend, only had our user-tailored front end. We had, it was an advantage, we had hierarchical data that could be handled in our system then. But the problem was Fedora 4 couldn't handle OAI PMH anymore, so they discontinued. The developer community just dropped out of OAI PMH, sort of. So we had a lot of extensions, CMDI extension. We had a shell extension so that we could operate everything on from the back end via shell access. We had binding to of CMDI to each digital object to make sure that we actually had that. We had our own OAI PMH provider. We were still using the handle system as a persistent identifier. That was CLARIN recommendation, and so we used that. So we have a problem. So now the good question is, where's the problem? So one of the problems that we are facing now is end of lifetime Fedora Commons 4. Shouldn't be much of a problem. We can just keep on running the old version. But we had a problem. There were security issues, etc. And we didn't see a clear path to a new Fedora Commons solution. So this is something that's going to happen to you at some point, that not with Fedora Commons maybe, but with the whatever system you're using, you will have to switch to a new thing. So Fedora Commons used specific libraries that had some security vulnerabilities. We had a temporary solution, great. We raised our firewall, so of course we had to drill some holes in the firewall for OAPMH and stuff like that. And you can imagine that this is a security nightmare at the end. And so it was clear that at some point we would have to migrate to a different system. And when we thought of migrating to a different system, we thought of our users, so the data providers. And we looked at our metadata and we thought, well, if we maintain things and move stuff to new systems, we should basically look into the metadata and see what's in there and make some quality assurance. I mean, it's 14 years old, the oldest metadata files. We would do it completely different by now. So we learned on the way how to do it better, 14-year-old stuff. And so we looked at the metadata and our users weren't there anymore. They retired, they went out of the academia, didn't answer their emails, things like that. I mean, it just happened. So asking someone, can we change to a CC BY non-commercial license instead of give me a call if you want to have my data, that was just not possible. I mean, it's so. We had an access control list with all of these old users. They haven't logged in into the system for 10 years, but we still have them because they are the owners of the files. They are the owners of the data. So we had a temporary solution to move to a data steward model. So the benevolent dictator, as Dan told them. So we have a data steward who looks into the data and the metadata and looks what they can do with the data, give it out, pass it on, etc. So 2018, we ran a preparatory project with some central university institutions. So they were running Fedora 4, we were running Fedora 4. They were running the handle system, we were using the handle system. They had AAI installed, so Shibboleth, no problem. Okay, they had a different handle prefix, but everything else seemed to be fine. And we ran some tests, and copying the digital objects seems easy. In direction of handles, well, you just update the handle to resolve to a different handle, so it was possible. But the user management was a nightmare. Well, if we use the data steward model, then it's easy. If we keep the original users, it was a problem. The central infrastructure didn't support CMDI. It didn't support rich metadata that is discipline specific. It was basically Dublin core. Or in some arbitrary library standards they were used. And so they didn't have a certificate at that time. and they didn't support part identifiers in the handle system, and access control was a challenge. So we didn't port our data to this other thing. We just had this preparatory project and thought, well, if we really need to do it, we know how to do it and we can do it. It will come with a prize. So then we started to search for the Holy Grail and said we have to do something now. Well, that was about 2022. And so we looked around and saw that there's the institutional central infrastructure that is now committing for long-term solution, keeping everything on the long term. And we couldn't make sure that we had a long-term administration and funding at our CLARIN Center for maintaining the repository systems. So we thought that's great that our university has a central infrastructure for data management. Let's go there. So it wasn't tailored to the CLARIN needs, but it was just like, you can use it, take it or leave it. And well, at that time, they weren't running disciplinary repository. So what happened later was, when we found out that we have to find a different solution, the funding perspective was clear for the central infrastructure. We saw that our Fedora common systems was a security hole. We knew that we were not able to port to the newer Fedora Commons, and it's not an ideal candidate for moving there because the community of Fedora Commons moved in a completely different direction. We thought of implementing the stuff for ourselves based on Oxford Common file layout, looked into Dataverse, etc., Invenio. So we switched to Invenio because we thought that's a great community behind that. That's something that we can trust for the next 5 to 10 years, that it will be kept operational, probably longer with the community given. And that was our decision. So now we had some challenges. Handling of CMDI data in Invenio, yeah, we can do that. But out of the box, it doesn't support it. Invenio, out of the box, works best with DOIs, not with the handle system. It doesn't, so the complexity of Invenio is gigantic, so you have to find someone to set it up. So the good thing is, our central and university infrastructure, since our first projects where we had Fedora Commons 4 systems, they moved to Invenio. So we were able to use their system as well and move there. So we looked at our data and saw what we can move on to the Invenio system of our central infrastructure and migrated everything to Invenio. We have some digital objects that we found out that's actually literature, so we moved it to Zenodo instead of Invenio, of our Invenio system. And we saw that there is other metadata types on the horizon in Invenio. So we thought that's a great thing. So our migration concept contained 3 different steps: authentication, authorization, metadata harmonization, and persistent identifier management. I'm rushing through these. Authentication and authorization with a data steward model was no problem at all. Metadata harmonization, that posed to be a problem. Invenio based on data side, basically. So we had a mapping from CMDI, from our CMDI profiles to data side, and we keep the original rich metadata as part of the digital object. The only problem that we had was So the central university's repository does not provide CMDI over IPMH. So we were aware that we will have to keep our own IPMH provider. Well, we already had that before. It's still the simplest solution for us. And we know of some solutions that we will hear of in some later CLARIN conference of other institutions that actually have a way of providing IPMH, CMDI from within Invenio over IPMH. So we will just get the SIMD from our Invenio system with a cron job every night, provided through our own IPMH provider. And the persistent identifiers, that was actually the tricky part. This is the really caveat. We used part identifiers before in handles. DOI don't support part identifiers. So if you use part identifiers, get rid of them. It's really, it's non-standard, it's always running something on your own system. Just don't do that. We know that now. We didn't know 10 years ago. So, last slide. So here, so on the left-hand side, you see a screenshot with our old system based on the handle. It is a CMDI file, basically, with transformation with XSLT into HTML and what have you. On the right-hand side, that's an Invenio. If you've seen Invenio, that's just looking like Invenio with some other logos. But so we have this DOI and the handle. So if you use either one, you will now end up with the on our Invenio system. So the old handle will now resolve to the DOI, and the DOI will resolve to this page, and we have the full functionality here based on the, and we are future-proof now for the next, let's say, 10 years, whatever. So the next core trust seal will be easy to get based on the new system here. Okay, thank you.
Well, thank you for paving the way for the rest of us. We have time for 2 questions.
Thank you very much for the presentation. You mentioned that new Fedora versions, there were no alternative for you. May I ask why? Because meanwhile, Fedora is at version stable 6. And if you look at their portfolio, there are a lot of big institutions and libraries and so on using it. And I'm asking because we are now setting up infrastructure in our institute, and we are looking for different systems. So I'm interested why you neglected the Fedora versions.
So when we did our evaluation of the different repository systems, the first thing we found out is that all of them are supported by huge infrastructures and organizations. That's purely marketing. That's what we found out. So it can be a very small, tiny group sitting somewhere at one of these institutions, like Library of Congress has some developer group in visionaries who do this or that system. So if you see a list of institutions supporting something, don't believe it. So look at what's really there. The second thing is we had so many bad experience with Fedora Commons, with the institutions, with the porting from Fedora 4 to 5. There was no way, no upgrade path, and following the discussion with the developers, it didn't look like they're going to do that for research data management. So if it fits to your needs, take it. But if you So with our old system getting into the new system, it's just as good as switching to a completely different one. So Fedora Commons is now all RDF-ish. So it has definitely its merits, but for our data, it didn't seem to fit anymore.
Thorsten, thanks very much for your presentation. With my administrator hat on, I feel your pain. And I wanted to second you on your point about centralized decision-making, the benevolent dictator for restricted data sets. So we offer this in Finland also as a service to everyone, and we encourage everyone to consider whether they trust us enough to make the decisions on sharing the data for restricted data sets ourselves. They can always take it back, and this actually makes life a lot easier, because of course if they are not there anymore to take it back, then it's at least clear who's responsible.
It's really a nightmare. People retired 5 years ago and they said, oh, I will always answer my emails. No, they don't. They don't.
Thanks for your presentation, and we can recognize a lot of the problems. I would suggest, since a lot of people have to implement the infrastructure and so on, that we have some best practices or some suggestions, because I feel the technical personnel sometimes are a little bit lost. So thanks for it, and I don't know, it's more a request to the center office, actually.
Yeah, the tricky part was selecting the license. I mean, how bad can it be? I mean, you decide once, don't accept, oh, they should call me. No, that's not a license. I mean, use a standard license. Even if you just close it up, it's better than to just have things like that. It's a decision they have to take. It doesn't cost anything, but if you do not have the decision, you're ending up in trouble 5 years later. And similarly with the access restrictions, if you describe it, a data steward will be able to decide for you or help you out, and they will be able to say, oh, this is definitely a commercial use, they didn't want it at that time. So even if we will support Creative Commons 7.x next year, it really doesn't matter, so you will still be able to understand this kind of thing. But if you have this, please give me a call licenses, it's a nightmare. Don't do that.
So we thank Thorsten for the lessons learned.